So yeah, we're going to be talking about React and Redux and how they play together and what they are. This is meant to be an introduction to React and Redux. Being that I only have an hour or hour and a half to do this, I'm going to go kind of quick because there's a lot of stuff to cover. But hopefully I'll have a couple points that we can stop and ask questions. But hopefully it's not too bad to understand. So what we will be covering is why React, rendering in React, updating components, JSX, component props, life cycles. So this is all the React stuff that we'll be covering. And then here is all of the Redux stuff that we'll be covering. So in React, why should we even use this framework? So some of the nice things about it are that it is declarative. It has a really reusable component structure. It's very fast to render because it uses virtual DOM as opposed to manipulating everything in the HTML DOM. It has clean abstractions, and it has really great developers tools, which we'll touch upon a little bit in terms of both for debugging and just for overall use. I find them very handy when I'm creating a React app. So rendering in React is fairly straightforward. So in order to do a basic hello world, we have this JSX here. So it has a div, which is just like any other HTML. And it has document, get element by ID, and then app. So if you're looking the HTML, there's just a div with an ID of app. So nothing really fancy here. And you can see it produces hello world. So that's what we're going to see repeated here. So getting into JSX. So JSX is more or less the templating technology that React uses. And it saves you from doing like the old school string concatenation and that type of stuff within JavaScript. So it allows you HTML-like syntax, but in the context of your JavaScript. Now, just being coming from the world of Angular and some other frameworks, initially this was a little bit off-putting to me to see like HTML in JavaScript, and I was like, oh, didn't we learn a lesson? Like, didn't we say this is a bad thing? But what you'll see, and I kind of just let it go with me, and what you'll see is because of the way that the components are structured, it makes sense because of the fact that the components are so small that it's not like you're writing mounds of HTML code and sticking it into your JavaScript. And everything is kind of grouped together sensibly, or at least it should be if you write it well. So it's not that bad. And then if you're coming from like Angular as an example, you're already doing that. You're just under the guise of it being a .html file, you still have logic that's happening in there. Same thing if it's Ember or Backbone or whatever, you still are using logic, whether it's handlebars or whatever. So it's not all that different. So updating components in React. So we have this tick function here. And then we are just rendering this element, and then we're just setting an interval that will re-render this element every second. So what does this produce? This produces clock. So what we'll see is that while this code works, it's not exactly how we want to pattern our React app, but it just gives you an idea of the fact that these components are stateless, and you're just re-rendering them.
Sorry, Jeff.
Yep.
The second component in render
Yep.
was the get element by ID app.
Mm-hmm.
So that is actually selecting in DOM where that template would replace?
Yep.
Okay.
Yep.
So, and what is that template a div, or does it actually put it inside the get element, whatever the app element is?
Yeah.
Or does it replace it entirely?
Yeah. So we can take a look at that. So what you can see is that it actually puts it inside.
Okay.
So the way that you would want to properly abstract that out is, hold on. Oh, okay, sorry. So one thing to note here is that the way that components are structured is that they pass in props, which are properties of that component. And these properties are passed down to provide dynamic attributes. So such as the props.product URL, the name, etc. So each one of these functions is a component in and of itself. So you have a product image and you have a product. And you can see how you can easily compose these. So you can notice product image. I'm passing in the product here. And then I'm accessing that here. So props, product URL. So you can see how you can take these components and quickly compose them together into greater components. And then down here, I'm just passing in the data. And in the render block, I'm just passing in this data product and then executing that. So all of this code just results in a display here where you have the image and a bit of layout. So there are two general types of components in React. There's container and there's presentational. They can also go by different names. You might hear them called functional versus class-based component, stateless versus stateful, or dumb versus smart component. But basically, the container components, they focus on how things work, and generally it's a class, a JavaScript class, not a CSS class, to be clear. They have state, and they extend the React component. So you get all the properties of a React component. While presentational, they focus on how things look. They're generally just a function. They only contain props, so they cannot have state to them. They read from the props and they invoke callbacks on the props. So in terms of the state lifecycle, let's go back and look at that clock example and do it a little bit more the React way of handling this, which is taking the state aspect of it and like abstracting it out so that it's clearly defined. So what we have here is we have a function that will format the date, which if you're used to Angulars, would be very similar to like a filter. And then we have this class, clock, which extends the React component. We have a constructor where we pass in the props and the state, and we define the default for the state, which is a new date object. And then we have these helper methods, which is component did mount and component will mount. So basically what this is saying is once the component has mounted or been rendered to the view, execute this script. So this is a tick timer with a set interval. And then we also have component will unmount. So this will remove the interval when you remove the component, because we don't want to just leave a bunch of interval timers running when we're not really using them. And then we also have this tick function, which will set the state. So we have this dot set state, and then we have the new date. And then in the render, we just return the a div with the formatted date, which is up here. And then we're passing in this dot state dot date. And in this case, we're rendering out 3 clocks. And we're just calling to render the app. So the result is we get 3 clocks. And they're all in sync. I know it's a little bit hard to see in that. Here. So we get 3 clocks. They're all in sync because they're all managing from one state. Yes?
Just had a question about the syntax that we're seeing there. Is that mainly ES6, or is that specific to React, or is it just a combination?
Yeah, so a lot of what you're seeing in React is ES6 or ES Next implementation, and that's the prescribed way of doing things. What you'll learn later in the talk is that we're using Babel to transpile, and that's why you can see right here it says Babel. But yeah, so we're going to use the more modern syntax because it's more terse and it reads better, in my opinion.
And the HTML just listed directly like that, but that is particular to React.
So this right here, so this is JSX. Because we have this render function, and then we have the anything that's contained within these parens is rendered as JSX.
Okay, so is that like a pre-processing layer as well on the code rewrite?
Yeah. So in that regards, what this will actually output is all the traditional like concatenation syntax, but this is a way of doing it so that you don't have to type that.
Okay.
So it saves it. It basically puts you in the HTML context, as opposed to I'm gonna have to concatenate all this stuff and.
That actually gets converted into JavaScript while the concatenation, and then like I'm sure later in the talk, there's reasons why they have to do that, but it just makes it so much easier. Just to, if you're familiar with HTML, why would you want to write all these JavaScript classes and functions to concatenate everything together? Just write your HTML and that's important.
Yeah, I see how it's easier. I'm just kind of like, well, where's the ES6? Where's the JSX? Where's the one? Yeah.
It's JSX.
Yes.
That's what it is.
So JSX will just automatically look at a name for a tag and see if it's a class that you created.
Yeah, so in terms of the syntax to denote that it is a component, you use capitalization. So what you'll see here is, see how clock, I don't know if you can see that, but clock is capitalized. That signifies that it's a component. So anything in lowercase is just an element, while if it has title case, it is a component. So that's how you will know, and that's how the interpreter knows what to, like, where to pull it from.
So for this component, you have the JavaScript and the HTML inside one file, but where is the CSS? I see you using class name clock.
Yep. Yeah, so the CSS is just right here.
So it's in the same
So-
folder next to the component?
Yeah, you can structure it any way that you want. What is the prescribed structure is that it falls within the module. So yes, in the same folder
Same folder.
is usually the way that you'll see it.
Is there a way where you can include it in your component as like JSX magic or?
So you can,
It's a style tag. Right?
yeah, so you can include it within your component. You import it. There you'll see kind of later on, there's ways to using what they call CSS modules that will actually change the class name to make it unique so that you don't have any like collisions
That's awesome.
in your classes, which is really nice.
That's fine.
Yeah. So yeah, that I found that also super handy. So events are very similar to the regular DOM events. The only thing, like some of the things to note that's slightly different is use camel case. So as opposed to onClick all being lowercase, use onClick camel case. And then you have to prevent the default explicitly instead of just returning false. No need to call add event listener. That's handled for you. And make use of the constructor in class to add a handler method to a component. So, sorry, it's a little short here, but so we have this toggle, which has a constructor, which has a state of is toggle on, and that's set to true, and then we bind this click handler. So this binding is necessary to make this work in the callback. And then the handle click, it sets the state to the opposite of what it's currently. So that's how a toggle works.
Can you go over that again?
Yeah. Totally lost. Yeah.
Is that what's going on?
And then you just have this this render with Boolean. So the result, this is super exciting. It's on, now it's off, now it's on. And guess what? Now it's off. So that's how events work. Pretty straightforward. The one thing that I really like about React, and this is kind of, I guess to Aaron's point, like which of this is native JavaScript and which of this is React specific, what you'll find is that the majority of this is native JavaScript. And so when you're looking at like, oh, well, how do I iterate through a list? Guess what? It's exactly how you iterate through a list in JavaScript. Like you don't have to remember like this custom syntax. Not that it's super complex, but it does create some like overhead of like, oh, ng repeat versus a map or something like that. So you'll see that kind of time and time again. So I created this quick example, and it uses the Create React App CLI. So the React team provided a CLI tool, a very lean, stripped down CLI tool that provides you with some boilerplate and allows you to get started on a project. Because this is only React, I thought, oh, that's great. So I use that. And then I'm also going to show you some of the React developers tools, and you could see some of the power that you can do with the dev tools. So without further ado, here's the example. So it's a tip calculator. So not super complex in terms of its functionality, but what it's doing is it is illustrating all the things that we've learned up until now. So you can put in an amount, you can say how many people, and then you can be generous and give them a big tip. And you can see that it outputs all of this. So let's take a look at the actual code that was required. But before we do, let's actually do some inspection here. And yeah. So one of the things you'll notice is like, like, oh, well, I'm just in the same, elements view that you normally are. Yep. Yeah, maybe. I think so. Yeah, make it bigger. That's good. Good stuff. So what it might look like initially is like, oh, well, I'm just in the normal like element view of the Chrome DevTools, but you're not, because you're actually in this React tab. And so you get a different set of information here. So what you're actually seeing is these are actual components within React. And not only is that valuable so that you understand like the hierarchy of how everything is structured, but you also have this understanding of what is on any given component. So if you look on the right, you can see like, oh, this is a prop that's read-only, and it has handle tip, which is bound to update tip, and here are the values that are put on there. So you can have a very clear understanding of every component and the state that it's in and what it has bound to it, which is super helpful when you're working with other people's code, as well as yours too. I mean, maybe you didn't know what you did, but anyways, it's super helpful to see like the current state of the application and what the data is doing. So you can also see that on some of these there's actual state happening, and you can see what the current state is within the application. One other pattern to note is that when you're working with React, the preference is to minimize the amount of class components that you're using, so components that contain state. You want to keep as many like stateless functional components. And the reason why you want to do this is kind of for a couple reasons. So for one, stateless components, super easy to test because they're just pure functions. You know what you're getting in and you know what you're getting out. And there's no side effects, so there's nothing to affect the thing, so they're super easy to test. It would be just like testing a filter in Angular. So that's why you want to do that. And you also want to like limit the exposure to creating statefulness, because state is kind of a messy thing. So you want to isolate that and limit that to the minimal amount on your page. So here's the code. Hopefully you guys can read this okay. In the index HTML, we have this root item, which is a div. All the other stuff is kind of unnecessary in terms of commenting. Then it's just calling this, which just renders a tip calculator. We can see that we're importing a CSS class. So this is also behind the scenes using Webpack, just to note. So that's why we have access to import, which is like the native JavaScript for modules. So we're just importing React, React DOM, the tip calculator, and then the CSS. The reason why we have React DOM and React is because there's other variants of React that don't require DOM. So if we are working with React Native, which is to implement React on, let's say, an iOS device or an Android device, we'd be using that variant. And all our code would still work in theory. So anyways, stepping into this, we go into the tip calculator. And you can see here that this is a class. It has some state on it. So these are things that we want to track that will be interactions. Anything that changes over time is considered a state. And then we are calculating the tip, updating. And then we have some DOM here where we're calling other components. And some of those other components are here. But all in all, it's super straightforward to use, and I found it that it was really nice to have everything be functional, so that I don't have to think about maneuvering like scope and state, and it's nice to have all that isolation. So getting back.
Can I have a question?
Yeah, sure.
On the JSX, is it possible to move to another file or you just embed in one file?
I think in theory it would be.
That's what.
It would be possible, but it's not the preferred method.
Okay, that's my second question.
Yeah. So the preferred method is to keep all your component, because essentially, especially in like stateless components, which the majority of your components will be, like if you look, that's kind of all there is. You're just.
In the file, you have a like big chunk of JSX.
Yep. Yeah, so that would be in a class component. And I could, if I wanted to, I could actually break those into smaller components so that I don't have quite as much HTML in there. But yeah, so it's really your class components that are gonna feel a little heavy. And if you're worried about the size of your class components, you could always pair that out into a stateless component, and then put the other stuff. Like, so basically you're just saying like, oh yeah, this is just a component in and of itself. That's just a stateless component, and then all the state stuff that's happening is in your class.
Okay.
But yeah, the prescribed functionality is to keep that all in the component. Yep. Any other questions?
So on this particular one, okay, so tip button gets past handle tip, and it's,
Yeah, so one of the things that you might notice here is like, again, some ES6 syntax sneaking in here. So the curly brackets within the parens means that you're destructuring these so that, because otherwise I would have to call like props dot, etc. So like this is a way to shorten up your calls so that you're just passing in, like you just have to say handle tip as an example.
It also looks weird because of the arrow function. Like, yeah, so that's you get an object in past 10, and then it's going to destructure those to.
Yeah, and because of the fact, like in ES6, because of the fact that the kind of the left and the right side of the object are the same, you don't have to, like, I don't have to say handle tip colon handle tip, label colon label, because the fact that they're the same, it will balance them out
okay.
when you're
And then
destructuring.
I guess the other thing.
Yeah.
The constructor is just needed when you extend React.
Yeah, so constructors are only used in this framework for classes. So like if you're looking,
But also the constructor is specifically used when you're trying to extend the component, or the class is used when you're trying to extend the component.
yes,
Okay.
yep,
Cool.
yeah, the class is used when you're extending the component and then also to introduce state. So functional components don't have state. So yeah, so let's move on. Redux, yay! How are we doing on time?
Developer tools?
What's that?
Like,
Oh, it's just a Chrome extension.
okay.
So just through the Chrome extension store. So we're doing kind of okay. So why Redux? So provides predictable state manage, it's easy to test, it has excellent tooling, and it's unidirectional data flow. How does it work? So the way that Redux works is that it has one immutable store, and it is essentially a state manager. So it manages the state of your application. It contains actions and reducers. Actions trigger changes. Reducers return the updated state. So we'll go into those in detail. So here's the basic Redux flow. So coming from React, you dispatch an action, which then goes to the store, which then looks at the reducer, which is a slice of the store, and then it kind of returns it back, which returns it back to the component. So let's kind of go through this flow because it's a little bit hard to see that conceptually. So with the Redux flow, so the first thing that we do is we need to provide a way for the whole React app to have access to the store. We do so in a component called provider, and then we bind to it the store. So in this case, store is the store component within Redux. So the store holds the application state. It allows you to access this state via getState. And it allows the state to be updated via a dispatch action. And how do you create a store? Essentially, you import create store from Redux. You import, in this case, you're importing a reducer. for this example, it's to do app, and then you say let store and then create store to do app. So in this case, this is like the root reducer. So in the React component, use connect to map the store's state and dispatch to the props of a component. So if you see here, we have these kind of helper methods here, which is map state to props and map dispatch to props. And so what this will do is this will provide us kind of the return of the state. And then this is mapping these events. And then we're using, in our export statement, we're using connect to bind these two to the store that we've provided in the overall app. Then to dispatch an action. So basically an action is any change that you want to make on to the data. So anything, or more specifically, that the user wants to interact with. So they fill out a form, they click a button, they do any type of interaction, and we need to update the state of the application. We do so using actions, and we dispatch those actions. So we dispatched props. We then dispatch, and we pass in the topic name in this case. All right. So selectors, this is something that is a little bit more advanced, but basically what selectors allow you to do is they allow you to compute derived data, allowing the Redux store the minimum possible state. So these are used more once you get into asynchronous flow to kind of prepare the data. They're composable and can be used as inputs to other selectors. So as an example, if you want to get visibility filter, and then you have the state here, then you want to get, this is another one to just get the list of to-dos. And then you create the selector. You then do a case statement, and then you return the filtered information back to the state. And then the default is to just return the full to-do list. So with actions, after you dispatch the action, this is what an actual action is. It's just a plain JavaScript object. Every change is an action, and it's essentially this type. So type is how you identify an action, and then it has a payload, and that payload is the data kind of going back and forth from the from the store. And so actions create and send the data from your application to your store. They're the only source of info for the store, and they send to the store using the store.dispatch, and they must contain a type. So the way that you're using type, so this will identify which action you're calling. So essentially, in your reducer, you'll have a series of case statements that will respond according to this action. So next we go to reducers. Reducers tie the state and action together. They are a function that takes a state and an action. as an argument, and they return the next state. So in this case, what it's doing is it's taking the existing state from the store and the passed in action. And then we have a switch statement here that just checks to see the type of action and then returns the appropriate action. So with reducers, they specify how an application state changes in response to an action. They're based on array reduce, so that's where they got their name. They keep the data separate from the UI state. They're a pure function. They take in the previous state and the action, and they output the new state. So you want to think of the app state as more or less like a database of state. And then they keep entities in objects with IDs, and IDs are used for referencing it in other entities or lists. So the way to think of the store is, so each one of these would be a reducer, and it's a slice of the whole, which is the store. So this allows you to kind of break up your application into kind of manageable chunks in terms of, so that you're not like pulling the full state store on every call. You're just focusing on the part that you need and updating the part you need. So things you never do with a reducer. So mutate its argument, perform side effects like API calls or routing transitions, call non-pure functions, as an example, date now or math random. How to use a reducer. So you import the action, initialize the state, use a switch statement, change the state. You can use object assign without mutating it. Use default to pass the previous state. So moving on, to middleware. So one of the things that you might have noticed is that since everything is trying to keep this like stateless, pure function structure, but as an example, like API calls run there. So like, how am I going to create a dynamic app without API calls? Be a little bit difficult. So they introduced this concept of a middleware, and this handles all your side effects. So anything that's stateful, this will handle specifically API calls, logging, crash reporting, routing. All those types of things are handled in middleware. So there's 3 popular middleware for handling API calls. So there's Redux Saga, Redux Thunk, and Redux Promise. Redux Saga is the most popular. So what are the differences between these? So Redux Promise returns a promise. Redux Thunk returns a thunk, and Redux Saga does not return a saga. It returns a generator. So that's something new to ES6, or I think it might even be in ES7. But anyways, it's new to JavaScript. And so that's what I went with, was Redux Saga. And we'll experience that a little bit. I didn't want to, because we're running short on time, I didn't want to get too much into the Saga workflow, because we'll be here all day. So, so other libraries. This is the one thing that with React didn't necessarily put me off, but it increases the learning curve. So because React in and of itself is, I think of it more as a library than a framework. So like Angular is a framework. It's like, it does all the things. Same thing with Ember. It kind of does all the things. But with React, it does not do all the things. It does one thing. It just focuses on the view aspect of things. So in order to manage state, you need Redux. And then what you can see here is these are all the kind of helper libraries that I've used in the demo app that I'm about to show you. So things like immutable.js, which always makes a copy of the state so you don't have to mutate it. Reselect caches the previous tree state to boost performance and compute. So like, and then there's also Redux Saga. There's also some stuff for internationalization, and the list kind of goes on. There's also routing for Redux Router. There's CSS with modules. There's post CSS, testing. There's Enzyme, Jest, Mocha, as well as needing Webpack, Babel, and then some of these other helpers like the Redux Dev Tools, the React boilerplate, and prop types. So there's a lot that you can kind of have to digest. So, what I like to do is to just start simple with just React and then add these as you kind of see necessary. But yeah, that being said, let me show you the demo here. So this was an app that I created for this talk, and it kind of illustrates all the stuff that we've been talking about so far. So it has this little slide out tray, and I'm able to select different sections. I'm also able to add and it adds it to the list. Then even if I go back, you can see it's still added there. So still overall fairly simple interactions, but you can see that it's using a lot of these different things that we would do in our everyday work for application design. So let's actually take a look at one of the flows for this. And you can see this is actually has a lot more complexities to it. So we have this app directory, we have components, and we have containers, and we have tests and translations, and so the two main parts that you're going to be really kind of focusing all your time in is these containers and components. And so the containers are like classes and things that have state in them, and components are just the little elements that build up. So let's actually walk into this linked list container, and you can see here, so a lot of this is actually, the boilerplate is provided with the React boilerplate. So I can quickly spin up with answering a couple questions, like how do I want this component to be structured? Do I need it to have Redux? Do I need it to have Redux Saga? Do I need it to have translations? So a couple quick questions, and it kind of sets all this initial structure and wires it up for me. And even provides some tests out of the box. So just going into here, I'm just going to focus on one kind of path. So we have this dispatch props. So I'm gonna go through and request the links. So then this goes over to the actions that we talked about. And with the actions, they have a type and they have a payload. So in this, it's the topic name. And we also have this request links succeeded. So this is where we'll actually get the links. So we need to get the name first. So that's why we have two functions here. So, and then we go from here, we go over to the reducer. And you can see here we have that switch statement with the request links succeeded. And we're setting the state with the links. And we're passing in the action links. So, and then that gets passed back to here with the, it gets passed on to the state. So that's it in a nutshell in terms of what we have for code. And a lot of this is similar, and I just don't have the time to show you every little aspect, and it'll probably be a little boring to see repetitive stuff. So I'm going to skip back to here, and I'm going to take this out of presentation mode. And I wanted to show you Redux also has dev tools. And so what do we have going on here? So I could probably do a whole talk on the Redux dev tools as well.
Do you mind?
But yeah. Yeah, what are you doing this afternoon? But so the great thing about Redux and the fact that it has this immutable store that is logging all these events over time is that you can actually play these events back. So you can do what they call, very marketing speak, time travel debugging. What I call it is, yeah, you can move the slider. But yeah, so what this allows you to do is kind of like a stack trace, but it's a little bit more powerful in that you can actually rewind your events and see what the state of the application is on each event that's happening. And in this case, we're dealing with the sweep. So like these are, if you noticed, like it, even though that I opened this up after, it has all the events that I did. So it has the ads, it has the switching between things. So you can get a really clear picture of, oh, well, this is doing a state change. This is a knitting. This is a router to location change. And then there's the payload, there's the state. So you're getting like all this like in-depth information that you can drill into, which is really powerful for debugging. Like when you're trying to parse through like a series of events and trying to find specifically where it's breaking, you can go like down to each call and you can see like where it's happening in the state. So I think that's really powerful. And then you can also either step back or you can use this slider and you can actually move through time. And you can see it actually erased all the. Yep. Yeah. So let me switch to split view. Oops. I don't like it that way. Let's do it. All right. So I've now went back in time to when I initialized the application, and I want to play all of that back. So you can see it's stepping through all of these things and calling up the different renders, and it's actually playing back the actions that I'm doing.
It's like replay
Yeah.
a video.
And so that's super cool. The other thing for testers that's, I think, even cooler is you can actually export this and import it. So,
Right here.
yeah. Yeah. Yeah, so, when a tester, comes back and says, hey, I went through this scenario, like, they can send us that as a JSON object. I can import it in, and I can, like, replay that whole session. So, like, to me, that's, like, super powerful. And I can see, like, oh, yeah. And along the way, I get every insight of the data. I don't just get a screenshot video of them playing back the steps. I get, like, all the data that was happening to them, that whole path. So I think, like, to me, that was kind of the icing on the cake in terms of why you might want to use a tool like this. Yeah.
Does it track all that data just because you have the dev tools downloaded, or does it do that in all instances?
So it is doing that normally. You're just surfacing it with the dev tools. So this is because the store essentially is all of that. It's that JSON object of all the states and the changes to the states.
Because the state is immutable, it's actually making a copy.
Yeah, exactly. Each time it's making a copy, so you have all of those states. So I think that is definitely one of the things that I would like to see in other frameworks that I haven't yet really seen that level executed. So that concludes. I did pretty good on time. It's 1:07. So I'm opening it up to questions, comments. I did that good. I don't get any questions.
Well, I guess this is more just a comment.
Yeah.
Like myself, I grew up, doing programming, and then later did web development. And so during that transition, there was a lot of for example, CSS selectors was always kind of like, what does the greater than symbol mean over here? And there's a dot, and there's pound, there's a lot of stuff to learn.
Mm-hmm.
One cool thing about React is that I was hoping you were actually going to show a little bit of it, is that you can do inline styling, and you've been told forever, don't do that, it's horrible. But it's basically, the inline styling is just a JSON object, and then you can dynamically change it on the fly based on your state. And that's extraordinarily powerful, because there's times whenever creating a kind of class or trying to select and trying to manipulate it, dynamically can be really, really challenging. And here it's trivial. And I find that really, really powerful. I also find that having, a lot of times we're told oh, we need to break apart our styling and stuff. Well, a lot of times what happens is that you have an enormous style sheet you can't find shit in. It's thousands of lines long, you're trying to find stuff, whatever. Here it's right next to the component, and you can see exactly what's happening. So I find maintenance on it is actually really, really nice, even though it's breaking all these traditional rules we're told not to do. So anyway, that was kind of my impressions when I was playing with React and my own little side projects. I thoroughly love it. I haven't used any Redux, but that is really cool. The whole playback to state, that's phenomenal. I mean,
Yeah.
imagine how many times users could come and say, hey, this is my problem, especially QA. And we've all seen the videos or the like screenshots. We just did this moment, like, what is this? I have no idea. I don't even know what database you're in. But having that stage, you can immediately play back and go, oh, well, here's the problem right here. I mean, so that's really powerful.
Yeah, and one of the things that I really liked about it was, so what you noticed was, or I don't know if you did, but I didn't have the dev tools open immediately. I didn't have to hit record.
Yeah.
So, because a lot of times when you're running into these issues or these, these anomalies when you're coding, you're not always recording and you're not always like, I mean, how many times has it happened to like, okay, now I need to go check the network tab. Oh, I need to refresh the page and get all the network stuff because it wasn't recording all that stuff. So like, it has all that data. So when you experience the anomaly, you can pop it open and be like, oh, let me replay that and export that.
I guess that my question is the state is stored on the server, is it, or?
No, so the state is all stored in the client. So you can, in essence, you can do some, you can do isomorphic, which means you have both server and client code with React. It kind of goes beyond this talk, but there's definitely that capability. But all that state is because it's just the interactions that the user has done while using the application. So
Like it's stored in the local storage or something like that?
it just gets persisted in a JavaScript object.
I was wondering about HTTP calls and how, so say you have this big payload, and then you're like, okay, well, I need parts of that payload on my state, and you just like asynchronously assign it to the state, and then.
Yeah, sorry. So one of the things I kind of skipped over, and this was due to timing, was that whole Redux saga.
Okay.
So let me just
Depending
kind
on
of.
time, we can.
Oh, we'll make time.
Yeah. So this is the saga file for that particular component. So some of the things that you'll notice that are a little bit different here is you'll see these asterisks or stars next to function,
Yes.
and you might be wondering like, what's that?
Is that C++ pointer again?
Yeah.
Holy crap.
So that is a generator. So generator is like a specific type. So think of it like a promise, but it's a generator, and that's what it is. So it's returning a generator object. This generator, generators are very similar to promises, but they have more functionality. Like you can pause them. You can like do a lot, because a lot of the issues with promises is like when you want to escape out of promises to like go down different paths and that type of stuff, you can run into a lot of issues. So this generators has that, they seek to solve a lot of that. But so what you can see here is that you have, so when you're fetching the links, so that's the links that are displayed on the page. You have a try and catch, which is similar to a then and catch in a promise. And then you're setting up the links, and then you're using call. Sorry, it's minimized here. My imports are minimized. Is one of these side effects. So what they call them in Redux Saga is side effects. So side effects is like anything that happens that will mutate a function. Yeah, which is in functional programming, it's called the same thing.
Yeah, data from the server is like, it's
Yeah.
not like internal, there's no state.
Yeah.
It breaks the statelessness.
Yeah, exactly. So what Redux strives to do, and React as well, is they try to isolate any changes and like kind of quarantine them, more or less. So in doing so, they create these side effects so that you can clearly denote them. And so this calls fetch links from server, which is up here. And then this is just using the JavaScript's fetch, which is like a new way to do asynchronous calls. Kind of simplifies the whole flow, which returns a promise. And I don't know. So there's a lot of like ES6 stuff happening here. So I can go into it. So like backticks are templates, are JavaScript templates.
Yeah.
So that's why you have access to this $. So it looks like it's, at an initial glance, it might look like it's specific to React, but it's not. It's just part of the modern syntax of JavaScript. So then, yeah, you're just passing in the topic name, and then you're taking that response and you're returning it as JSON, which then gets fed out to a yield and a put, and you put it to this request link succeed, which, where is that? It's here, which is that action.
Okay.
So that's in that actions file.
Okay, so when someone fires that action, this gets called. Or this
Yeah.
Is fired.
Yeah, sorry. So when
And
they call
it's
fetch
stored.
links, so once the links have successfully been returned, this is actually calling the succeeded.
Okay.
Which, so it's saying like, oh, call this action, which if you look,
Yeah, let's look on the other side.
takes this.
Okay.
So it takes the payload links, and then it returns that type, and then the payload links. So that's how it passes it back, which is, I don't know, pretty nice. The
Keeps
other,
everything like, yeah.
yeah, everything is like super isolated, which I like. And then they also have this helper generator, which is take latest. Some people might have noted like, hey, why does this yield, why do some of the yields have stars and some don't? So when, this is similar to when you're passing around promises and you're returning promises from promises, you can chain generators as well.
Yeah.
So in this case, this is a chain generator.
So it's a generator that returns a generator.
Yeah, exactly. Well, in this case, this is just a generator that returns. So like you can optionally chain generators.
Yeah, so I'd be curious like what generators add, and I mean it seems like you're still doing that then up there. Can you just like do? There's some value add for generators that I don't understand. It seems like.
Yeah, I think I haven't delved too deep into them, to be honest, but I know a lot of it stems into how do you handle exceptions, and like because with promises, like when you fail like one, it kind of like bubbles up and fails a lot of the other ones.
Yeah.
So like this is a way to like through this one you can be specific and you can still have it succeed, and so it's supposed to fix a lot of the promise chaining issues that you run into. But I'd have to dig a little bit more into the specifics of it.
Yeah. So like if you're doing multiple ton of calls and whatnot.
Yeah. It's just more extensible from, like, it does all the stuff that promises do and other stuff. So,
So the Saga file, so you can make it work without Saga. It's just a helper.
yeah, Saga is an implementation of generators for this. So, like, you could totally do that. It's not recommended because you're mutating the state. So that what they're trying to do is they're trying to isolate so that everything maintains testability. And in this way, like, it isolates everything. But you could totally just you can throw a fetch, because it's just JavaScript. So, like, you could throw a fetch anywhere in that chain. Like, to the same extent, like, you don't need Redux technically. You can just use state in React, and then when you call your update state, you can say fetch, and you can fetch the URL and then pass in that as state. But I find that when you go beyond this simple application, maintaining and managing state becomes exceedingly complex, and you definitely won't get any of the Redux dev tools, and you won't be able to kind of play back that state, and you kind of are destroying a lot of the built-in kind of niceties that they're providing by having immutable objects and that type of stuff. You're introducing side effects, you're introducing mutations in the data. So a lot of the benefits that you gain from React, you're kind of taking away. At least that's my opinion. But yeah, so at the end of the day, I think, you know, the apps are super snappy. So they run really quick, and, you know, I think that I prefer this flow over Angular's flow, and I definitely think it's more testable, and it's more scalable in its structure. We could easily, since these components are so small, they're super reusable, and since they're stateless, they don't depend on other components in order to function. So you can see us building a library of these components, and then being able to share those libraries across teams. So, yeah, sure.
So, when would you recommend using React and Redux over other frameworks? And also, is there any caveats of like using React apart from like the learning curve and all that kind of stuff?
Okay. Yeah, I think in terms of other frameworks, there's like good parts and bad parts to all the frameworks. So it depends on kind of what your timeline is and what you're trying to solve and that type of stuff. So, like, as an example, I guess one of the caveats or the downsides is that you are required to do a lot more of the legwork of figuring out like which one of these libraries, because it's a series of libraries as opposed to a framework. So a framework, the advantage in it being highly opinionated is that you have a path to go down and you have the prescribed way of doing things. So the issue that you run into often with libraries, especially when you're entering in, is it's a decision tree. So you have like all these different choices that you can make, and those choices, if you don't have experience in these, you might not be making the right choice. So there's definitely, that can be a big downside. Fortunately, React has had a great community, and so it's already starting to have kind of these clear winners in terms of like which libraries to use, such as Redux or React Router or Immutable.js or stuff like that solve these specific problems that you'll run into. But I think that's one of the stumbling blocks, if you would, is like knowing which library to use with what. And then in terms of whether to use this versus another thing, it kind of depends on what you're doing. I like the fact that React has this like isomorphic aspect. So if you're using an application that needs to be super performant, then you want to offload some of that to the server so that you're not initializing the whole application. So in doing that, isomorphic has some benefits to it. But yeah, I think there's times that you might not want to use React. I don't think that you should always use a framework. Like depending on what you're doing, there's definitely times that it's not saving you any time or benefit. Like if you're not maintaining state and you don't have multiple views and that type of stuff, using a view library is not going to do you any good. So that's what I would say to that. Any other questions? Nope. All right. Well, thank you.
Are there any like services where you can like kind of like New Relic, where you could, because it seems like, imagine like every time there was a bug in your UI, like it got put in, posted New Relic with the state trace and stuff.
Yeah.
You could actually like recall what happened to your user. I mean, like,
They
or
do
well,
have-
the QA thing was.
Yeah,
But
they do
yeah,
have logging and that type of stuff.
That'd just be, I mean, it's like random, because like in New Relic they'll like randomly grab sessions and attach like a listener, and you can actually see they click buttons, but it doesn't really work that well because like mostly it's just trying to.
Yeah, there's a lot of noise in that.
Yeah, it's just all framework noise too.
Yeah. Yeah. I believe that there is logging.
If not, I imagine someone should have built that because
Yeah.
I mean it's kind of niche logging, I guess, but.
You should do it.